Good evening, or good morning, or good afternoon. Today in this video, we're going to be going over our first quiz. This video is going to be rather short because other videos kind of have covered what's going to be on the quiz. But in this case, I am just going to straight up go over it. So on the screen right here, you'll see our quiz. Due Friday, October 2nd. You have 2 tries immediately. If you want a third, wait a week, you'll have access to that. On this quiz, you'll have 7 or so multiple choice style questions, right? Matching, ordering, multiple choice, that kind of deal. And 3 short answers. We're going to be going over what topics we're going to cover here. This quiz will be covering learning targets 1 through 4, primarily learning targets 1, 2, and 3. Well, there is one other 4. So let's go and check. Let's go ahead and zoom in. And so one of the questions, I'm just going to go ahead and start with assignment number 2. Actually, assignment number 1. No, assignment number 2. Starting with our notes here. And so with the beginning of school year, at the beginning of the school year, we started with what is chemistry, right? After that, we deal with energy. Chemistry, in reality, is just the study of energy as far as chemical bonds are concerned, right? The energy in those bonds. And so to start off, we investigate the energy inside of food, right? So our first lab of the year was a calorimetry lab. The purpose of this lab is to see how energy is transferred from one thing to another. And so to walk us through, a question I'm going to point out here is, what do you think heat is? Heat is literally everything. Cold as a concept doesn't exist, right? If you're cold, what you are is not warm, right? You're not heated up. And so what is heat? Heat is not the opposite of cold. Cold as a concept doesn't exist. So if we're talking about what is happening to our almond as we burn it, right? Any food as we digest it, we're taking these sources of energy and we're turning them into energy that we could use to breathe, move our bodies, move our hands around as needed. And so what we're going to go with right here, I believe, right. So what we're going to move on to very quickly is our second set of notes, but I'll get to that later. I really want to drive into the fact that when we are burning objects, right, we take energy that is stored as chemical energy in the food and we burn it, right? That's turning into thermal energy. And then from there, if we burn it inside of our bodies, we take that heat and we are able to use it to transfer it over into other forms of energy, mechanical, electrical, right? The neurons in our brain. And so there is energy transformation happening here. Okay? And so as we did this lab, we know that there are sources of error involved. And this is something I'm also going to be quizzing you guys on. Sources of error. Where do things go wrong? Now, I'll be jumping around at this point to various places on your evidence notebook. So let's do this. The first thing I want to point out are units, right? We measure energy in several types of units: kilos, hectos, decos, decis, centi, milli, to go even further, mega, giga, micro, nano, right? We have different units here, and it's important we are able to recognize which is the smallest and which are the largest in that order, right? That has to be something we just get the hang of. Okay. So jumping around, we're going to jump over to density. That was an assignment 3. There we go. Let me zoom in. So the formula for density is given here. I'm not going to give you the formula for density on your quiz because you should have it in your evidence notebook. As far as density is concerned, it's mass over volume. as far as mass is concerned is density times volume. The units matter, but more importantly, what's going to matter in your quiz is the significant figures. So there are points of it here. Let's just take our number 4 example. We have two numbers. We have the volume, right, 1,062 milliliters. That's 4 significant figures. Each of those numbers are important. 1062, 4 significant figures. And the density is 0.023, right? And the questions ask, what is the mass? So you'll find a very similar question on your quiz, but what is going to be asked is, what is the mass, but according to the correct significant figures? And so the density here is 0.023. That is 2 significant figures. The zeros at the beginning don't matter. And so identify which, how many significant figures are in each number, do the math, and then drop out the numbers until you get to a correct point. So 1062 times 0.023 will give us this mass. But significant figures tell us that only 2 of those numbers are important, and it's the first 2. So we just drop the rest. 24 grams is our answer here. On your test, you might find something similar where you're asked to find the density, right? Figure out the significant figures for the numbers you're given, and then perform the calculation. Your answer should be pretty obvious at that point. Next up, we're going to go talk about percent errors. Now, I've talked about it before, and I'll talk about it again. Percent errors are how we talk about accuracy. If you have a high percent error, that implies you are inaccurate. You did not do a good job at doing your experiment. You have a low percent error, lower than 5, lower than 10%. You did a pretty good job at being accurate. And now to do these calculations, what you need, you could do it in a calculator. You could do it in Google Docs. It doesn't really make a difference. What you need to do at the very least is your value from your experiment. The value from the experiment minus the actual value. So if I'm calculating densities and I calculate, this density is 2 grams per milliliter, but in actuality it's 1.5 grams per milliliter, I do 2 minus 1.5 divided by 1.5 times 1,000 or times 100. That setup will give me a percent error. If you have a negative value, just don't make it negative. It's always a positive value as far as percent errors go. The question you'll find on your quiz will ask you to do this 4 times. And that's really why this test is 25 minutes long. I want to give you plenty of time for this math. You'll have about 2 questions with significant figures. So going right past that. And let's talk about holding hot things, right? If I'm holding, let's say I'm asking you what heat is. Let's say I'm holding a hot mug of coffee. Hot mug of coffee. Hard to see with the camera. Hot mug of coffee. Cold does not exist. Heat does. My hand is pretty chilly right now. If I put my hand on top of my cup, what is heat doing? Heat is being transferred from my drink into my hand, warming up my hand. So what you should be seeing here is heat being transferred to the place without less heat. Think of like a hill, right? You want to balance out your energies. And so heat, which is energy, will go to the colder spot. If I have a cooler object, right, if this coffee suddenly became very cold, what would happen is that the warmth of my hand, that energy would travel over to the cup. For the people in my class who have significant others, if you ever hold someone's hand and it gets really sweaty, that's heat being transferred from hand to hand. It's kind of gross when you think about it. Don't get in relationships. You're too young for that. So, next up, we're talking about the notes we've done before. Right after assignment number 2, we did, open this guy up, 2 sets of notes. 2 images here will become very important in your quiz. This is the first one. All energy basically is either potential or kinetic, right? It either does something, it does an action, or it's waiting to do an action. It's potential. And so I'm just pointing this out, right? No real rhyme or reason. I'm just pointing this one out. It may be on your quiz. It may not. It may be easy points if you have this slide open. It may not. It's up to you. What I'm going to point out next, though, is what happens to energy as we, what happens to particles as we increase the energy. So I want to direct you to the slide. Thermometers. Thermometers, as you know them, have liquids inside of them. You guys know that. What you may not know is that the reason why thermometers move up as the temperature gets higher is because of energy inside those particles, right? You heat something up, the particles inside that liquid will take it in, and it's something like, I need somewhere to go. I'm very excited. And so it moves up. Slowly but surely, it moves up and expands its space. And so this is something we're going to get the hang of. As it cools down, right, those particles bounce around less. So they'll just take up less space because they don't move around as much, right? Think about someone hyped up on caffeine or an energy drink. They'll bounce around. They need a lot of space. As soon as they calm down, they take a nap, and you can kind of just put them on the couch and they don't move anywhere, right? Low energy, low space, low volume. High energy, high space, high volume. So if you take some things and you add energy, it's going to need more volume. Otherwise, it might burst. I hope I don't get DC. I hope my channel doesn't get banned for this image. It's, I'll be copyrighted. Okay, and the last thing I really want to cover, as far as quiz is concerned, will be conversion. I've done a lot of practice with this, and I'm going to keep it up. Number 9 is probably your best bet here. In number 9, we have a package of food. We have 1 serving is 36 grams. 36 grams is 110 calories. You want to know how many calories are in 0.15 pounds. And so the plan is where you always start. You take your pounds and you're going to turn them into kilograms or grams if you can manage it, right? You could easily Google 1 pound is 453 grams. That's easy. Doesn't matter. You turn your pounds into grams somehow. You turn your grams into calories using the conversion factor that is already up on your page. 36 equals 410 calories. It may not be the case that you'll have this written out for you. You'll have to write it down yourself. I can't do everything, so that part is going to be up to you. You'll find questions on your quiz like that. I say questions, it's really just one. So you may not be able to write a table on your Schoology, and so I'll just take the final answer as is, as you could write, as best as you could write it. Just do your work on some paper, and I'll take the final answer. And that pretty much sums up what is going to be on your quiz. Let me put it up here. You're going to have to know your units, right? Kilograms, hectograms, decograms, centigram, that kind of stuff. You're going to need to know how density is calculated. And on that note, you're also going to need to know significant figures. You're going to need to know how to do percentage errors. That is straight up math. Can't get around it. You need to know how energy is transferred, right? If I'm holding a cold drink, energy is being transferred from my hand to a cold drink, and it's going to warm it up. Or vice versa. If it's a hot drink and it's going to my hand, energy is going to my hand. Think of water trying to level itself out. It can't always be up here. It will try to level itself off. You want to know about potential energy versus kinetic energy. You want to know about changes in energy as we burn food, as food is burned, and unit conversion. So there are 10 questions on your test. You've got 1, 2, 3, 4, 5, 6, 7-ish topics, so expect a few things to be repeated. But overall, this is a quiz, right? Not really high stakes, but it does kind of impact your 10 week. Don't stress too much about it. You do get an immediate retake if you want. And then next week, you could also retake it one more time. It will be slightly different. So that is all for today and this video. Hope you have a wonderful rest of your day, and I'll see you all in the next one.